Okay, welcome back, and today we're going to continue with section 3 of chapter 3 on logic. And so we're going to talk about truth tables for negation, conjunction, and disjunction. So what are truth tables? That's the first thing we're going to talk about. Okay, so we're going to use their definition of negation, conjunction, and disjunction. We're going to construct truth tables and determine the truth value of a compound statement for a specific case. So truth tables are tools that will tell us under what truth values a particular statement or compound statement is going to be true or false. So if we look at a truth table, it's just we list the first column or the first couple of columns depending on how many statements you have. For example, we have one statement, and the first column always is going to tell us the number of possible values, the truth values. So if P, well, the two possible values for P are either true or false. If that's the case, then not P, the negation would be false. If this is true, then this is false because this means opposite of P. So if this is true, then this will be false. If this is false, then this will be true. Now what about if we have a conjunction? Well, in this case here, we write out P and Q. So again, this is a truth table for a conjunction. So an and statement. And we write out all possible values of the different combinations of truth and true and false, right? So we have T, T, F, F, and then we have T, F, T, F. So we can either have both be true, we can have this be true and this be false, or we can have this one be false and this one be true, or they're both false. So this column here represents all possible combinations of truth values. Okay, so we have this. Now, under each one of these, when is an and statement true? Well, if they're both true, it's true. Otherwise, the rest of them are false. So what does this tell you? That a conjunction is only true when both statements, simple statements, are true. Otherwise, it's false. So I like to tell people, hey, when can you say that you're lying? Well, in an and statement, if both statements, both simple statements that are being connected are not true, then you could say that the person is lying. If I say I'm going to the movies and I'm going to hang out with my friends, and I don't go to the movies, or if I don't go hang out with my friends, let's say I go to the movies and I don't hang out with my friends, can you say that I lied? And the answer is yes, because I said I was going to do both. So if you don't do both, then you lied, right? Now what about disjunctions or statements? Well, say again, we do our truth table. A lot of times we'll write a. I usually, in the way I was taught, I did these in separate columns, and so that's what I like to do is to write these in separate columns. So I would put a line here, and I would just have these as separate columns, as long as you keep them straight. Okay, so we got true, 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 false, false, true, false, false. Or you can go TT, FF, and then TF, TF. Okay, now or. When is an or statement false? Well, the only time an or statement can be false is if both of the simple statements being connected are false. So if I say I'm going to the movies or I'm going to hang out with my friends, as long as I do at least one of those two things, you cannot say I lied. But if I don't do either one of those things, then you can say I lied. So a disjunction is only false when both statements, simple statements, are false. In comparison to a conjunction, where the only time that a conjunction can be true is when both simple statements connected are true. Okay. Now, what if we use this example here? It says let P and Q represent the following statements. So we say P is the statement that 10 is greater than 4, and Q is the statement that 3 is less than 5. Now, both P and Q are true. So, but we're going to use that to find out what the truth value is. So it's an and. So an and statement can only be true if both of these is true. Well, is P true? Yes. Is Q true? Yes. So both of these are true, so this is a true statement. What about this one? Well, as soon as this is not P, well, that means is not P true? Well, if P is true, which we know it's true, then not P is false. And therefore, the whole thing is automatically false. Because remember, the only time an and statement can be true is if both statements connected are true. Okay. Okay, so now let's look at the same example. So let's look at this one. P or not Q. Well, remember what an or statement is, right? An or statement, only one of the two has to be true. So at least one of the two has to be true. Well, P is true, so therefore the whole thing is automatically true, even though this here is false. Okay, so not Q is saying that 3 is not less than 5, which is a false statement because it's clearly is. Okay, and so even though not Q is false, P is true, and as long as one of the two statements is true, then we have a true statement. Now here, both P and Q are true, which means both, in this case, both of these is false, which means, in this case, the or statement, the disjunction here, is false. And so, here we go. How do you construct a truth table? Well, step one, you list the simple statements, in this case P and Q, on the top, and show all possible truth values. So again, if you know the pattern, it's easy to write these out. So this is going to be true, true, false, false. And then you cut it in half and you go true, false, and you repeat the pattern. Okay? Or you could do true, 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 false, false, true, false, false. Okay? And then you can see by just plugging in these values, you know when it's going to be true, when it's going to be false. And it's easier if you just remember conjunctions are true only if both statements are true. Disjunctions or just disjunctive statements are false only when both statements are false. Okay, now in this truth table here, we're going to find the value, the truth value. So here, what do we get? Well, we start with P and Q with all the possible truth values, right? Look familiar? Then we're going to do the conjunction. So the dominant connective here is and. So we know that this is going to be TFFF, okay, because the only time this is true is both of these are true. If there's any F's, it's false. So now we want the negation of P and Q, which means we're going to take all of the truth values here and we're going to take the opposite truth value. So this means this is going to turn to F and all of these F's turn to T. And we're done. Okay, so in this example says P, Harvard is a college. That's true. Yale is a college. That's also true. So what is it saying? It's saying it's not true that Harvard and Yale are both colleges. Okay? And that is what? That's going to be a false statement. Now, if we get a compound statement that is true no matter what truth values you have, that's called a tautology. And this is not a tautology, because if it was a tautology, we would have T's all the way down. If this was a tautology, we would have T's all the way down. if we have just one F, if we have at least one F going down the column, it is not a tautology. So again, a tautology is a compound statement that is true regardless of the truth values of the simple statements that are being connected in the compound statement. So now, if we want to construct a truth table for this, well, again, we do it piece by piece. We start with the first two columns with all possible truth values for the two statements that are involved. And then we start building bit by bit. So here we've got a not P here, we've got a not Q. So the next column to have, I would do is not P and not Q. Okay, so not P is all of the opposite of these. So FFTT. Not Q would be the opposite of these. So FTFT. Okay, now, what about this? This is not P or Q. Well, here's not P and here's Q. So remember, or statements are true or false only when both of these are false. So what you do is you look at those two columns. So we're going to look at these two columns. And we're going to see where, oh, we have it's an or statement. So there's a T here, so that means this is going to be true. There's a true here. There's no true, they're both false, which means this is going to be false. There's a both true, this means true, and we've got a true, which means we've got true. So it's going to be true, false, true, true. Okay, and then finally we're going to connect this one and this one. So now what we're going to do is we're going to look at these two columns. And this is an and. So and statements are only true when both statements being connected are true. So this, there's no true, there's an F here, so this is false. There's an F here, there's a false. There's an F there, false. Two trues, true. And so we finally get our final result. Now what about, in this case, we have three statements. Well, notice the pattern. Now, half of these are true, half of these are false. Okay, so true, 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 false, 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 false. And then you go to the next column, and now it's going to split in half again. So here we've got true, true, false, false, and then it repeats true, true, false, false, and then it splits in half again. True, false, true, false, true, false, true, false. Okay, and that's one pattern you can see. Okay, now you can also see a pattern if you look at this. We start with T's, and then we start going through our patterns for this one. True, 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 false, false, true, false, false. And that's with the first one being true. And then all we do is change to false, and we repeat the pattern. True, 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 false, false, true, false, false. And you get the same one. So either way, notice that when we had one statement, we had true, false. We had two possible outcomes. And with two, we had now four, so it doubled to four. And with three statements, it doubled again to 8. Okay, so every time you add a statement, it doubles the number of possible combination of truth values. Now, constructing with 8 possible, and we won't do any more than any more than 3 statements, just so you know. So 1, you study hard to ace the final, or I failed the course. So I study hard and ace the final, or I fail the course. So what we're going to do is we're going to take this sentence and we're going to create a truth table for it. So let P be I study hard, and let Q be ace the final. I ace the final, and then let R be I fail the course. So there's our PQR. So we start by looking at the statement in symbolic form. I study hard and ace the final, comma, there's the parentheses, right? So I study hard and ace the final, comma, or I failed the course. So now that gives us an idea of how to set up our construct our truth table. So here's our 8 combinations of truth values. And then we're going to do P and Q. Well, what's P and Q? Well, if we look at these 2 columns here, okay, this is going to be true when both of these are true. Otherwise, it's false. True, true, and the rest are going to be false. Right? Why? Because we've got F here, F here, F's here, and of course, both of these are F's as well. Okay, and so that's where we get TT, and the rest are going to be F's. Then, for the last one, we're going to look at these 2 columns, because this is the dominant connective. This is the connective that makes the truth value of the whole thing. So now we're connecting this statement and this statement with an OR. So we're going to look at these 2 columns. So anytime there's a T, it's going to be true. The only time it's false is if they're both false. So this is going to be true, this is going to be true, true, and then false, true, false, true, false. Okay. Now, I study hard and ace the final, or I fail the course. Okay? So now, this is the completed table, and right in the given statement, what do we want? We want to know constructed truth table of the following statement. Okay. Now B says, suppose that you study hard, you do not ace the final, and you fail the course. Under these conditions, is the compound statement true? So in other words, this is true, this is false, and this is true. Okay, so we got true, false, true. So if we look at for true, true, false, true, well, what does that mean? Well, for part B, let's see. So for part B, we want to find the row that has the same truth value. So true, false, true. So this is the row that we want. So under these truth values, this statement here is true. So now we can use a truth table, and given the truth values, particular truth values of the statements, we can decide and find out if the statement as a whole is true or false. Now, specific cases. Now we can determine the truth value of a compound statement for a specific case in which the truth values of the simple statements are known, just like in the previous example, without constructing the entire truth table though. Okay? You just have to think through it. We can substitute the truth values of the simple statements into the symbolic form of the compound statement, then use the appropriate definitions to determine the truth value of the compound statement. So for example, we don't have to use the truth table. Okay? So now, in this case here, it says a bar graph shows the distribution of looks for American men and women ranging from homely to strikingly attractive. Okay, so notice the distribution. okay, for men. So this is the distribution for men. This is the distribution for women. Percentage of American adults that fall into both of those categories, or each one of those categories. Now, it says use the information in the bar graph to determine the truth value of the following statement. It says it is not true that 1% of American men are homely and more than half are average. Or it is not true that 5% of American women are strikingly attractive. So how would we do this? Well, we're going to take each one of these statements, right? So we've got statements here. So it is not true that 1% of American men are homely. So 1% of American men are homely, that's P. And let's say more than half are average. Let's call that Q. And let's say 5% of American women are strikingly attractive is R. So we got three statements there, right? So we could say 1% of American men are homely, more than half of American men are average looking, 5% of American women are strikingly attractive. So we can find the truth value of each one of these statements. So here, 1% of men are homely. That's true. Half of American men are average. More than half. That's true. And 5% of women are strikingly attractive. That's false. Okay, so now we know that this statement is true, this statement is true, and this statement is false. Okay, so it's true, true, false. So now we got to put it together. Okay, so we sign the letters. Now let's put it together. It says it is not true. So that's going to be not P. Here it's going to be and. There's an and. Oh, there's a comma right there. So that means that everything before the comma is together. And so we can say not P and Q. Okay. It said is not true that 1% of men are homely and more than half are average. Okay, so it's not true that 1% of American men are homely and, so this is all together. The not true part is saying it's not true that these are both true. And so that's why the negation is outside. We're saying it's not the case that these two are, that it's this and this. Or not are. Okay, so this is the compound statement. Now, what do we know? This is true, true, false. So if P is true and Q is true, that means this whole thing is going to be true. So the way we could do it is by putting the truth values in for the letters, like this. So now we know that this is going to be true, right? Because this is a true statement, so we can say not true, right? So this is true, so we can substitute this for not true, or not F, right? So that just follows along. Now we have not true, which is what? False. Or not false, which is true. And so we get false or not true. Well, obviously this is going to be a true statement because we've got a true. And so the disjunction is true when at least one part is true, right? So guess what? We just proved that this statement is true. And that's the end of it. Okay, now, remember, oops, hold on. So now remember that practice these things. Go through the examples in the textbook. Don't just listen to the video and that's it. take notes. If something doesn't make sense, write it down. If you have a question, write down. Go to the textbook. Do some of the examples in the textbook. Go to the suggested homework problems that I have on Blackboard. Make sure you practice those. And if you get stuck on something, reach out to me or bring those to class, because that's what we're going to work on. That's what you want to bring up in class in groups or start working on. And because the sooner you get started on this, the sooner you're going to ace the homework and you're going to do well in the quizzes and the exams. Okay, so I'll see you in class. Until then, keep practicing and make sure you're taking good notes, and I'll talk to you later.